Today we're tackling the ZDTE. That's 60 questions, 90 minutes, and 60% to pass. Welcome to this custom deep dive designed just for you. Okay, let's unpack this and get to question 1. So, when a brand new, unknown third-party app is first detected in the app inventory, what status is assigned to it by default?
Well, if you're an admin, there's a really strong cognitive bias to assume your expensive security tools are just actively grinding away. So you might argue for the trap, which is option C, reviewing.
Right, because it feels like the system is actively working on the problem.
Exactly.
But is it actually an active state, or is it more of a waiting room? Because the real answer is D, unclassified.
Yeah, it's parked. Think of it like a bouncer pulling someone out of line at a club. You don't just wave them in.
Which eliminates option A, sanctioned.
Right. But you also don't instantly throw them out onto the street, so that eliminates option B, unsanctioned. They just sit in an unclassified holding area to prevent premature trust.
Speaking of analyzing unknown entities, let's look at files. For question 2, how many distinct rounds of analysis does the Zscaler sandbox perform?
This is a tricky one. People usually fall for trap D, thinking it's just one static round and one dynamic round. Like you look at the code, then you execute it in a safe room.
It sounds complete.
Right, it does.
But wait, what about the mess left behind? The actual answer is A. It's static, dynamic, and a final static analysis.
Yeah, and what's fascinating here is you have to evaluate that mess. In the real world, it's like a bomb squad detonating a package. That's your dynamic phase.
Right.
But they don't just walk away. They meticulously analyze the shrapnel and artifacts left behind, which is that final static round. This completely rules out B and C.
Well, sandboxes analyze file behavior, but what about looking inside image files? If a file is an image, which specific category of sensitive data can be identified and protected using OCR technology?
I mean, people hear sensitive data and jump straight to the trap. Option D, financial transactions. We're wired to think of banking flows, you know?
Sure, but what's hiding in a driver's license scan? We're actually looking for option A, PII.
Precisely. Optical Character Recognition essentially lets the data loss engine read text inside non-text files. It's literally like X-raying luggage at the airport.
Oh, wow.
Yeah, it's not looking for software licenses or network configs, so B and C are out. It's hunting for identity data.
Protecting data is great, but where do we process this without lagging the local network? So for question 4, what is the primary advantage of deploying a local private service edge, or PSE?
The common misconception here is trap B, assuming it just completely replaces the app connector.
That would fundamentally break the architecture. Before we reveal D, think about localization. The real advantage is D, it localizes ZTNA policy enforcement.
In the real world, it's like having a local branch manager who can approve a transaction on the spot instead of calling headquarters for every little thing.
Drastically reducing latency.
Exactly. So A and C are out. It enforces policies. It just does it locally.
To enforce those policies, you need the right structural pieces. For question 5, what are the foundational config blocks for app protection?
Watch out for trap A here. People order them as controls, profiles, and policies. It has all the right words, but the exact wrong flow.
Right. The system needs context first. The correct sequence is D, profiles, controls, and policies.
Think of building a house. The profile is your foundation, your baseline.
Okay. And the controls?
Those are the walls. They're specific countermeasures against threats. And finally, the policies are the locks on the doors. You can't enforce a policy without a control, so B and C are out.
But what happens if a lock gets compromised? Question 6 in the console. What is the immediate consequence of deleting a ZPA provisioning key?
Automation bias kicks in heavily here. Engineers desperately want the system to auto-generate a replacement key, which is trap D.
If only it were that forgiving. The brutal truth is A, all app connectors are instantly revoked.
It's not just changing a door lock. It's like changing apartment locks and instantly invalidating the old keys. Everything collapses immediately, so B and C are wrong.
Understanding these system responses requires specific training. Let's look at question 7 on the EDU 202 scope. What is considered outside the scope of this course?
People assume advanced courses skip the high-level stuff, so they guess trap A, the global architecture overview.
But the actual out-of-scope topic is B, managing client connector versions.
Right. I mean, EDU 202 teaches you to drive the race car, the core architecture. It doesn't teach you how to be the pit crew changing the oil.
That makes sense.
Yeah, that's what admin updates are. So C and D are completely in scope. And I think that wraps us up. Today we covered app inventory default classification, the sandbox analysis methodology using OCR for data protection, private service edge benefits, stacking app protection building blocks, immediate lockdown via ZPA provisioning key management, and the EDU 202 learning path scope.
If the sandbox evaluates the shrapnel, how might future AI predict those artifacts before they even execute?